Welcome to this course on HVAC duct quantity takeoff. By the end of this course, you will understand the basics of HVAC ducts. You will learn how to take off the quantity of ducts using different units of measurement, that is linear, area, and also in terms of weight. I'll also be sharing an Excel template where you can record all your quantity takeoffs. This single sheet of template will have all the unit of measurements, and according to your requirement, you can record the quantities. And at the end, I'll also be sharing a bonus lecture wherein I'll be explaining how HVAC ducts can be measured using POMI standards of measurement. So let's start this course. Hope you enjoy it. So let's understand what a duct is. So ducts are passages used in heating, ventilation and air conditioning to supply and remove air. If you see, these are the different shapes of ducts. This is a circular duct, this is a rectangular duct which is most commonly seen, and this is an oval shaped duct. So mostly a false ceiling will be hiding all these ducts, but you can also see ducts which is not hidden by the false ceiling. Like if you have seen in the shopping malls, you can see the ducts which is exposed. So mainly if the ducts are exposed for that aesthetic look, circular and oval shaped ducts are used, and rectangular ducts are mostly hidden by the false ceiling. So these are the three mainly used shapes of ducts. Ducts can be made by different materials. Some of them are galvanized steel ducting, aluminum ducting, polyurethane and phenolic insulation panel ducting, which is also called pre-insulated ducts. Then we have fiberglass duct boards, flexible ducting, fabric ducting and PVC low profile ducting. The most common material used is galvanized steel ducting. These are the different fittings of a rectangular type of duct. Here this is the rectangular main piece, this is the elbow, this is called the offset, this is the reducer. One duct of one size is reduced to another size. This piece is called transition. So this piece is used mainly to join a rectangular duct and a duct of some other shape, mostly circular or oval shaped duct, and this is a T joint. So these are the mainly used fittings of rectangular ductwork. So the ducts are mainly connected to two types of equipments. These are the air handling unit and the fresh air handling unit. The difference between these are, in an air handling unit, the air from outside atmosphere is taken into the air handling unit and it is supplied to the rooms through supply ducts. Then the air is returned back to the air handling unit using the return ducts, and this air gets mixed into the supply part inside the air handling unit itself. So that circulation takes place in an air handling unit, whereas circulation does not take place in a fresh air handling unit. In a fresh air handling unit, the air from the outside atmosphere goes into the supply duct and the return air goes back to the return duct and it is thrown out of the atmosphere. This does not get mixed with the supply part. So the difference will be explained in the next lecture with diagrams, so you will understand it more easily. Now again, the ducts are classified into different parts. These are supply air ducts, return air duct, fresh air duct and extract air duct. Supply air duct is used to supply, as the name suggests, and return is to return the air back to the equipment. Fresh air duct is mainly connected. It does the same function of a supply air duct, but it is connected mainly to the fresh air handling unit. The purpose is the same as a supply air duct. Usually supply air duct will be connected to the air handling unit, and extract air duct is used to extract the unwanted air from the toilets and the kitchen using exhaust fans or ventilation fans. Now there are some fixtures that is used to supply the air which is connected to the duct. These are the diffusers and grills. Diffusers are mainly the fixtures that you can see on the ceilings, and the grills are usually fixed onto vertical surfaces like walls or doors. So mainly diffusers are for horizontal surfaces and grills are used for vertical surfaces. The first difference that we'll be seeing is between AHU and FAHU. So AHU and FAHU forms the part of the HVAC system. These are the equipments that are used to cool or heat your buildings. The full form is air handling unit and FAHU is fresh air handling unit. Now what is the difference between both? AHU can recirculate some return air back to supply stream, whereas FAHU will not recirculate return air back to the supply stream. So to understand that, we'll see the diagrams. So if you see here, this blue part is your AHU and the yellow part is your duct. So if you see here, the bottom part is the supply part of your AHU and the top part is the return part of your AHU. So the air from outside flows into the supply part. There will be a lot of filters, then your cooling coil, fan, motors, and after that the air will slowly move through all these filters, fans, cooling coils or heating coils, and then goes into your supply duct, and then from the supply duct it is transferred to the different rooms through the various grills and diffusers. And from the rooms, this air will go back to the return grills or return diffusers and then moves into the return duct and goes into the return part of your AHU. So in AHU, what happens is that some of the return air can go back to the supply part. So this will happen in an AHU. So that is what it is said that can recirculate some return air back to the supply stream. So this flow happens in an AHU. But if you see in an FAHU, both your supply and your return part are separated. Here there is a provision given inside an AHU wherein the return air can go back into the supply stream. But in an FAHU, both the return and the supply part are separated, and the supply and return air will never get mixed up. The fresh air from outside will go into the supply part and go to the duct and it goes to the rooms. Air is returned back into the return duct and it goes outside. So there is no mixing here happening in the FAHU. So hope it is clear. So in this video, I will be explaining how the length of duct measurements is done. So basically, all the duct pieces are measured in a linear way and the fittings can be included or it can be separately enumerated. So it depends upon the standard method of measurement used in your project and the BOQ, what it specifies, what your project requirement is. If it is required that a fittings needs to be enumerated separately, only the length of the rectangular pieces are taken and the fittings are separately counted. But if the requirement is that the fittings also needs to be included within the linear measurement, then the measurement is taken of the center line over the fittings. So I'll explain it using AutoCAD. You can see if it is a normal rectangular piece, you can easily find the length. Like the measurement will be always be from the center line. So you can just measure like through the center line and you'll get the length. You can click on the center part and then measure. So you can get the length here. Now imagine if it is an offset. So one duct is coming from here and there is an offset piece. This is an offset piece. This red part is offset piece and it is connected to another duct. So in this scenario, what we can do is you can just use P line and then click through the center part of the duct. So you got the length, and using T length application, you can easily find the length of this part of the duct. So if you have an application called T length, you can click TL command, click on the object, just press enter, you will get the length. Now this is a reducer. There is one duct coming 300 into 200 and it is connected to another piece of duct 450 into 200. In this scenario, what we can do is this part will be till the center part of this piece, till here. This will be the length for 300 into 200 and the remaining will be from the center part till the remaining duct. So this will be the length for 450 into 200 piece. This is how you can measure the length throughout the fittings, that is through the center of the duct and over the fitting, center part of the fitting. Now imagine this piece coming, one duct is here 450 into 200 and this is a transition. It is connected to a circular or oval duct. So again, your length can be till the center part of this piece will be 450 into 200 and then this is a 200 mm diameter circular part. So that part will be from the center till the remaining. So this part will be the 200 mm duct piece length. Now in a T section, you have one 450 200 coming, then it is divided into a 300 into 250 duct here and a 250 into 200 duct. So here the lengths will be, the 450 into 200 part will be from the center part till here. This will be your 450 into 200 length. Your 300 into 250 length will be from the center part till here and your 250 into 200 length will be the part till here, this part. So this is the way you calculate the length of each part including the duct, the fittings. So here there's elbow also, I'll explain that also. The length will be here 300 into 200 and it is connected to an elbow and another duct is connected 400 into 300. So 300 into 200 part length will be from here to your center here, and your 400 into 300 part will be 300 into 200 will be till here, and your 400 into 300 part will be the center till. So if at all the fittings needs to be separately counted, only the rectangular part will be taken. So you will count, there will be the duct here, total duct length, you will be taking the length till here. Then you will count, this is counted as 1, and then the remaining duct, the white part is the duct. So you will length from here, this part to the remaining rectangular piece, you will be calculating the length, and the red parts will be separately enumerated. And all these can be recorded in an Excel sheet. So I've made this is an Excel sheet where you'll mention from which drawing you're taking off the quantity, from which AHU or which equipment you are taking the length. It is always better to calculate the length of ducts from each equipment, so there will not be any confusion. So from AHU 1 you are taking there, you need to mention what type of duct it is. If it is a supply air duct or a return air duct or an extract air duct, which floor it is. Then mention the dimensions, the width and height which is available in the drawing, then the calculated length, and then you can add a wastage of 10%. It is normally 5 to 10%. Then you can, this sheet is for including the fittings. So if the fittings needs to be separately counted, only the rectangular piece needs to be recorded here, and the fittings can be separately counted. You can mention the quantity. Again, the rest of the things will be similar. The type will be different. You will need to mention what type of fitting it is. So hope you understood how to take the duct length using a linear measurement. Now we'll look into how duct can be measured in terms of area. So for that we need to understand some formulas. So these are the formulas. So I'll be explaining these formulas by using the AutoCAD drawing and also a physical drawing of each duct fittings. So first we'll see the formula for the area of a straight piece of duct. So that is 2 into W plus H into L. W is width, H is height, and L is length. So if you see, this is a straight piece. So W is this length, H is this length, and L is the length measured. In an AutoCAD drawing, if you see, the size will be given, size for each duct will be given in your drawings. So usually the first number that is mentioned will be the width and the second part will be the height. So in this drawing, in this rectangular piece of duct, straight piece of duct, 450 is the width, 300 is the height, and then L you need to measure. So once you have all these, you can calculate the area of a straight duct. Now next is elbow. The formula for area for an elbow is 2 into W1 plus H1 into L1 plus 2 into W2 plus H2 into L2. Now W1, H1 and L1 are the length of one part of the elbow, and W2, H2 and L2 are the dimensions of the second part of the elbow. So if you see here, one duct will be connected to this part and it will be as per the design and route of the project. We can understand what is the width and height of each part. So W1 and H1 will be the width and height of the duct that is connected to this part, and L1 will be the length till the center of this elbow. W2 is this part, H2 will be this height, and the length will be the length of this part till the midpoint of the elbow. So if you see your AutoCAD drawing, see. So here duct of 400 into 300 is connected to the elbow piece, and it is connected to a duct of 300 into 200. So your W1 and H1 will be 400 and 300. L1 will be this part, and W2, H2 will be, W2 will be 300, H2 will be 200, and L2 will be the length of this part. Now we'll see the formula for offset. So for offset, it is 2 into W plus H into L1 plus L2. So if you see here, in an offset, a same piece of duct is connected, and due to the design or the route, it will be an offset is used so that there might be some other services going through this part. So that is why offset is mainly used. So the duct piece connected here and here will be the same. So W and H will be the width and height of that duct piece, and L1 and L2 will be, L1 will be the horizontal length from this part till here, and L2 will be the vertical length from here till here. If you see the AutoCAD diagram, so W and H will be 450 and 200. L1 will be this part, this length measured, and L2 will be the vertical length measured. The next piece is reducer. The formula is 2 into W1 plus H1 into L minus W1 plus H1 minus W2 plus H2 into L. So reducer is usually used to reduce a bigger size of duct to a smaller size of duct. So W1 and H1 will be the width and height of the bigger duct, and W2 and H2 will be the width and height of the smaller size of duct, and L will be the length of the reducer part. So if you see, for example, in this part, W1 will be this width because this is the bigger part of the duct. Bigger size duct will be connected to this side. So W1 is this, H1 will be this height, W2 will be the width of this part, and H2 will be the height of this smaller duct, and L will be the length of this part. So if you see the AutoCAD diagram, the 450 into 200 is a bigger size and 300 into 200 is a smaller size. So W1 H1 will be 450 and 200, and W2 H2 will be 300 and 200, and the length will be the length measured for this part. Next, we'll see the area of a transition. The transition is used to connect a rectangular duct to a circular or oval shaped duct. The formula is 2 into W plus H into L minus W plus H minus pi R into L. W and H will be the width and height of the rectangular duct, and R will be the radius of the circular or oval shaped duct, and L will be this length. So if you see the AutoCAD diagram, the W is 450 and H is 200, length is measured here, and the R will be the radius of this oval or circular type of duct which is connected to this transition. So here 200 is the diameter given, so R will be half of 200 mm. Last piece is T, and the formula is 2 into W1 plus H1 into L1 plus 2 into W2 plus H2 into L2 plus 2 into W3 H3 into W3 plus H3 into L3. So it will be, there are 3 ducts connected to a T fitting. So W1 H1 will be width and height of this one piece, L will be this length, W2 H2 will be W2 of this width and height of this part, and length is till here, from here to here. W3 will be this width, height will be this height, and L3 will be from here to here. See the AutoCAD diagram. The W1 will be 450, H1 will be 200, L1 will be this length till here to this part. W2 will be 250, H2 will be 200, and L2 will be this part, this length till here. W3 will be 300, and H3 will be 250, and L3 will be the length of this part. So once you have all the lengths, you can calculate and record it into your Excel sheet. So here you can, this part is the rectangular part, and this is for fittings. The fitting area is calculated separately. It is always better to calculate it separately. The rectangular pieces can be calculated separately. So you can mention, like previously as I have mentioned, as I have explained for the length takeoffs. Similarly, we can put all the column headings and also find the length, and then you can put the formula. You know the width and height of each rectangular piece of duct. You calculate the length as I have explained previously. Then you put the formula. Since this is for the rectangular pieces, it will be 2 into width plus height into length. So then you will get each part area. You can add a 10% or 5 to 10% extra as for wastages. Then you will get a total. Again, the fittings you can separately calculate using the different formulas that I've explained. So then you will get the total area of the fittings alone. Then that plus the duct rectangular part will be your total area. Then if it is required that a fittings needs to be counted separately, so this fittings area need not be needed. Only you can calculate the area of the rectangular pieces, then the fittings just needs to be counted separately. So hope you've understood how to calculate the duct in terms of area wise. So now in this video, we'll understand how to calculate the duct measurements by weight. So basically the steps are, first you'll calculate the duct in terms of area. After that, you will find the gauge type from the size of the duct. Now each gauge corresponds to a unit weight per area as per the different standards are there, like the SMACNA standards, or there are the ASHRAE standards, the DW144 standards. So each standards will have a particular table wherein it is mentioned for each gauge type what the unit weight will be. So once you have the unit weight, you will multiply the duct area with the unit weight to get unit weight per area to get the weight of that particular type of duct. So to understand this, we will see the SMACNA standard. So this is the table corresponding to a galvanized sheet. So if you see here, there is the gauge type mentioned, and corresponding to each gauge, see here this heading we have the nominal kilogram per meter square. So since you are finding out the weight in kilograms, you need to check this. So if the gauge is 26, the multiplication factor will be 4.42. If it is 24, it is 5.64. 22, 6.86. 20, 8.08. If it is 18, 10.52. 16, it will be 12.96. So how do you find out the gauge? For that, we have a table here. So this, if you see, there are two tables. This is for finding out the gauge as per SMACNA and if it is a low pressure glass. And this is as per DW144 standards, and that is for low pressure glass. Here we have the table for medium pressure glass, SMACNA standards, and DW144 for medium pressure glass. Now, what is the difference between low pressure and medium pressure? So the difference between low pressure and medium pressure is based on the duct velocity and the static pressure. So if the static pressure is less than 750 pascals, it is low pressure, and if it is more than 750 and less than 1500 pascal, it is medium pressure class. And again, if the duct velocity is less than 1500 feet per minute, it is low pressure class. And if it is around 2500 feet per minute, it can be, that duct can be classified into medium pressure. So it will be completely depending on your specifications, your design of the project. You can find out if the ducts are low pressure class or medium pressure class. And also based on the standards, if your project is following the SMACNA standards, you can use this table, or if it is DW144, you can use this table. You can download. I'll be putting this table as a downloadable file. You can use it, and while taking off your quantities, and it will be helpful. This document will be helpful for your HVAC duct quantity takeoffs. So for explanation purpose, I will be using this table. We are assuming that our standards, the project standard is SMACNA, and we are using low pressure class. So if you see, if your duct longer side is 0 to 450 or 451 to 750, then that means the gauge is 26. If the size is between 751 and 1000, it will be 24 gauge. If it is 1001 to 1350, the gauge size will be 22. Even if it is 1351 to 2100, then still it is 22. And if it is 2101 to 2500, it is 20. And above 2501, it will be 18 gauge. So how you can read through this table is, first you need to find out what your size of the duct is. So if it is 450 into 200, so that means your higher size is 450. So you need to see where it goes. So if it is 450, your gauge is 26. So if at all it is 800 into 600 size of duct, so that means your higher size is 800. That means it will be corresponding to here between 751 and 1000, and your gauge is 24. So if your gauge is 24, you should correspondingly check what your unit weight is. So for 24, it is 5.64. So I've converted these details into a format. So I've already explained till this part in the previous lectures, where you will finding out your duct size in area square meters. After that, you are adding one more column to find out the maximum size between your width and height. So once you get that, you put a formula of max. You are checking these two columns to get the maximum size. And from that, here you have your SMACNA table, the same table which I had showed previously. Basically, we use 26, 24, 22, 20 and 18. These are the main gauges that we are using, and corresponding to that unit weight 4.42, 5.64, 6.86, 8.08, 10.52. So these details I have transferred here. This can be the master format where you have your duct measurements in length, area. Till this much I have already explained previous lecture. So with adding these columns, you will get the duct measurement in kilograms. So in this one sheet, you will have all your measurements. You can check what the length is total, the area is, and also the weight. So here I have added a column called max, where you are checking for the maximum size between your width and height. You're comparing this two for each type of duct. So from that, you're comparing it with this table and finding out which gauge is it, and accordingly you have put a formula. So if you see under 26G gauge, the formula is if this size L5 is less than or equal to 0.75. So this is the 26 gauge, means it is between 0 to 750. So if it is less than 0.75, then you are multiplying your K5. K5 is the area which including your wastage. that is multiplied into the unit weight 4.42, and then you get your answer. If it is true, you get this formula. If it is false, you get it as 0. So this is the formula. I have put it everywhere. And if it is 24G, similarly, you are checking if L5 is greater than or equal to 0.751, and if it is less than or equal to 1. So if this is the range, that means it is 24G gauge. If you see the table, 24G, here it is 751 to 1000. So the same thing I have put here. The unit weight is 5.64. So you are multiplying your K6. K6 is your area into this part, 5.64. Similarly, I have put for 22 gauge, 20 gauge and 18 gauge. Here the fittings are separated. Again, similarly, the same thing is carried out here. It's just that you're checking the maximum size and correspondingly the gauge, and then multiplying with the unit weight. And if counts need to be done separately, you're doing your fitting count separately, like previously, which I've explained. So you get the total kilograms. So hope you have understood how to calculate your duct measurement in terms of weight. Now let's see the POMI measurement clauses. So mainly for circular, oval and flexible, the measurement clauses are almost the same, only it is different for rectangular type of ducts. So first let's see what are the clauses mentioned in POMI for measuring rectangular ducts. So in a rectangular duct, the measurement is done by weight. So all fixing supports are included, and if there are any intersections, there is no need of any deduction. So for measuring your duct by weight, first you need to know the size of the duct, the width, height and then the length. Using these dimensions, you can calculate the area of the duct, and from the area of the duct, we need to separate the ducts into different gauges as per the different standards. We have SMACNA standards, ASHRAE standards. So they have the classification of the gauges as per the different sizes of the ducts, and from that gauges we will get a unit weight measurement per square meters. So with these details you can convert your area into kilograms. Mainly the rectangular ducts are calculated in this way, and the length taken is along the center line of our fittings. So to understand that, if you see this drawing, this is a duct 950 into 400 and this is a duct 800 into 400. So while calculating your length, what we have done is, so this is a reducer. 950 into 400 is reduced into 800 into 400. So while calculating the length of 950 into 400, your measurement is being taken from the center of this fitting to the center of the next fitting. And while calculating the length of 800 into 400, see here it is taken from here length till the center point of this elbow. That is what you mean by length taken along center line of fittings. So fittings also is included. While calculating the weight of this rectangular duct, you are including the fittings also. Fittings are not separately calculated, or the weight of the fittings are not calculated separately. Finally, the insulation, how you are measuring the insulation. So for rectangular duct, the insulation is measured by area, and all the fixing and supports are included. So here, to understand what of fixing and support to see, here this is our duct, this is another duct. For joining, there are different fittings here. You have gasket, flange. So while calculating your length, you're calculating the entire throughout this duct, both these ducts, you're calculating the length over these supports also. You're not calculating it separately. So while calculating the length of the insulation also, that is the measurement for the insulation, you're calculating it throughout. That is what mentioned, that all fixings and supports are included while calculating your measurements and your insulations. Now for circular, oval and flexible, the measurements are same. So in circular, oval and flexible, the measurement is done by length. So compared to rectangular, which was in weight, here your circular, oval and flexible measurements are done by length. And again, length is taken along the center line or fittings, which I had shown before in the drawing. Here the difference is fittings are enumerated for each size of duct and described as fittings. So while calculating your length, you are not taking in account the fittings. Only the duct main pieces are taken into account, and all the fittings are separated and they are counted. That is the meaning of enumerated. So you count for each size of duct. So for example, 450 into 300 mm, you will have 5 elbows or 5 T joints. So for each size, you you are separating it, and then you are describing it as fittings in your BOQs and counting the numbers, and you're pricing it separately. The fittings are priced separately if it is circular, oval and flexible type of duct. And again, the insulation, the difference here is in rectangular ducts the insulation was measured by area, but in circular, oval and flexible type of ducts the insulation is measured by length along center line or fittings. So hope this small video is clear and helpful. Thanks a lot for watching this video. Hope you have got some knowledge on